Business Finance, Chapter 6. In Chapter 6, we're going to be talking about bonds. So the key features of the bond, if you'll remember some of these terms from Principles of Accounting, we have par value. That's often also called face value. This is the amount that the bond is worth at maturity. For most corporate bonds, this is $1,000. Now, bonds can have different face values or par values, but this chapter, for all homework and example purposes, is going to assume that corporate bonds are $1,000 because that is the most common. The next is the coupon interest rate. So this is the stated interest rate of a bond. It's usually the yield to maturity at issue, so that YTM equals yield to maturity. We would multiply our par value by the coupon interest rate to get what the coupon payment was. What a coupon payment is for a bond is a regular interest payment to the bondholders. This can occur semi-annually or annually. Semi-annually is the most common. Maturity is the years until the bond must be repaid, or we can have the maturity date. That's the end date of the bond. Yield to maturity, so we saw that on the previous slide, or Y2M. This is the market rate of return for bonds, or the discount rate used to value a bond. It's also called the coupon rate at issue. It's quoted as an annual percentage rate. So if you remember from chapter 5, we know that the annual percentage rate is just the stated rate, and that the effective rate of interest can be different. We also know that because bonds are so dependent on current market rates, that the value for them and the yield to maturity for them can change throughout their entire life. The longer the life of a bond, the higher the risk from interest rate fluctuations. Our bond value, so bond value is the present value of the coupons. Remember, the coupons are the regular interest payments, and the present value of the par value. That's the value, face value of a bond. Or we can also say the present value of an annuity, because if we remember from chapter 4 and 5, an annuity is a regular payment that happens on a regular basis. Those are the coupon payments for bonds. And then the present value of the lump sum, which is the par value or end value of a bond. So remember, we're going to bring in a lot of the concepts from chapter 4 and 5 as we're doing this. So as interest rates increase, present value decrease. And as interest rates increase, bond prices decrease. So there's a correlation. If interest rates increase and present values decrease, and the present value is the value of our bond, then we know that as interest rates increase, bond prices will decrease. And then the opposite will happen. If interest rates decrease, the value of a bond increases. The bond pricing equation. So where C equals the coupon payment, F is the face value or par value, YTM is yield to maturity, and T is the time number of periods. When we're using a finance calculator or a scientific calculator, N is the number of periods to maturity. I divided by Y is our period interest rate or the yield to maturity. PV, present value. PMT is our coupon payment, and FV is the future value, which is the face value, which is the par value. In Excel, we use the same formulas that we used for chapter 4 and 5. So we're going to use future value, present value, rate, the number of periods, and the payment. We're also going to do a couple of extra bond calculations, but we'll see all of those formulas within this PowerPoint. So for bond pricing specific bonds on our scientific calculator, we have the directions. First, the STD actual settlement date. So that's the when the bond ends or its actual maturity date. Coupon is our annual rate expressed as a percentage. So the actual redemption or maturity date, the redemption value as a percentage of par, how many coupons we have per year, 1 or 2, our yield to redemption, which is yield to maturity, and then the dollar price per $100 of par value. If we're pricing specific bonds in Excel, then we can either use the price function or the yield function in Excel. Again, where we have the settlement date, the maturity date, the redemption and price as a percentage of par value, the coupon rate and yield, and the frequency, number of coupons per year, whether it's annually or semi-annually, and the day convention. So whether we want a 365-day year or a 360-day year. You can see this example if we have a coupon rate of 10% with annual coupons, so once per year, on $1,000 par value, face value bond with a maturity in 5 years and a yield to maturity of 11%. So we can use the calculator, we can use the mathematical formula, which is the present value of an annuity plus the present value of the lump sum, or we can use Excel to calculate that. When our yield to maturity is higher than the coupon rate, it's called a discount bond. That's when the price is lower than par. If the yield to maturity is less than the coupon rate, then it is a premium bond, as we're going to see on the next slide. So here, the coupon rate is 10%, the yield to maturity is 11%. So this is an example of a premium bond where the yield to maturity is lower than our coupon rate of 10%. We also have a maturity of 20 years. So we can see the example using our scientific calculator, the example using the mathematical formula, and the example using an Excel formula. All things being equal, there is a relationship between interest and risk. So the longer the time to maturity, the greater the interest rate risk. The lower the coupon rate, the greater the interest rate risk. We can see that if we compute the bond prices and the yield to maturity, there's a graphical relationship between the bond price and the yield to maturity. There's also a graphical relationship between the interest rate risk and the longer term bonds have greater interest rate risk. So the longer a bond life is, 20 years or 30 years versus a 5-year bond, then we have to deal with much more fluctuations with interest in the market. We also have inflation risk, which we're going to get to later in this. So the relationship between the coupon and the yield rate. So if the coupon rate equals the yield to maturity, then the price and par are exactly the same. If the coupon rate is less than the yield to maturity, then the price of the bond is less than par, or a discount bond. And if the coupon rate is greater than the yield to maturity, then the price is greater than par, and this is a premium bond. Now, why is that a true statement that it's a discount bond or a premium bond? Well, as we talked about, bonds prices are reflective of their rate versus the current market rate. So if a bond's rate or their coupon rate is higher than the market rate, then their price is higher because it's more desirable. I'm going to earn more interest by investing in a bond than I am by investing in the regular market at its current interest rate. The discount is the opposite thing. If the bond's interest rate or coupon rate is less than what the market is currently producing, then that bond becomes less desirable to me because I'm going to earn less of a return on it than I would in the general market. As we can see from this, there's bond value versus the years remaining to maturity. So this looks at the coupon rate versus the yield to maturity rate when we're talking about a bond over a 30-year period and looking at that inverse relationship between the coupon rate and the yield to maturity and the interest rate risk, about how much interest rate risk there is. So if we're looking 30 years out, there is a much higher interest rate risk than if we're currently at the 0-year mark. The bond pricing equation, this is adjusted for semi-annual coupons. So if you remember, our original equation was looking at if we just had one interest payment per year. So this is the equation for if we have semi-annual coupon payments or 2 interest payments per year on a bond. So we have the coupon, C is for the coupon, we have 2 semi-annual rates, YTM is the yield to maturity, which is expressed as an annual percentage rate. The time periods or the number of 6-month periods to maturity. P is the number of years to maturity. So we adjust it to take into account that we're getting paid twice a year. So let's look at an actual mathematical example for semi-annual bonds. So here's a semi-annual bond that has a coupon rate of 14% and a yield to maturity of 16%. The APR is the yield to maturity. Our maturity is 7 years and we have 2 coupon payments. So if we have 2 coupon payments over 17 years, that means our number of periods is 14. Our semi-annual coupon payment is $70. So this is our annual interest rate divided by 2. And our semi-annual yield is the yield to maturity, or that APR, divided by the number of payments. So if the yield to maturity is 16%, then our semi-annual yield is 8%, or that divided by 2. We can look at these examples using our mathematical formula, using the calculator, scientific calculator, or using Excel. See that the bond value is $917.56. It is a discount bond because the market rate is higher than our coupon rate. We have a semi-annual coupon of $70 or annually of $140. The semi-annual yield, market yield, is 8%, and our periods to maturity are 14, or 7 years times 2 annual payments. Changes in the price due to change in interest rate. So with our interest rate risk, we have price risk. So long-term bonds have more price risk than short-term bonds. And low coupon rate bonds have more price risk than high coupon rate bonds because of the market fluctuations. We're less likely to see competition with high coupon rate bonds within the market interest rates. And we know that as we've seen interest rates fluctuate in the last 20 years. So we have price risk from interest rate risk. We also have reinvestment rate risk. So there's uncertainty concerning the rates at which our cash flows can be reinvested. So our cash flows from bonds are those semi-annual payments. And again, where short-term bonds have more reinvestment rate risk than long-term bonds because we have a shorter period of time in which to earn those interest payments, and high coupon rate bonds have more reinvestment rate risk than low coupon rate bonds. And we can see from this graph the interest rate risk and the time to maturity. So the value of a bond with a 10% coupon rate, 4 different interest rates and maturities. So you can see if our 10% interest rate, if we only have 1 year to maturity and the yield to maturity is 5% versus if we have 30 years. Now remember, if the coupon rate and the yield to maturity are exactly the same, so if they're both 10%, then the par value and the yield to maturity value are exactly the same. So you can see that this gets much, the changes happen a lot more when we have a 1 year versus a 30 year. And if we're looking at interest rate going to 20% or 15%, that if the market interest rate would increase greatly, then we would have a significant amount of risk involved with that.